So good morning, everybody. It's my pleasure to discuss with you fixed mobile convergence from a slightly different perspective. As just mentioned, the topic of my presentation is enabling converged connectivity by 5G. And the outline of my presentation you can see here. I will give some basic motivation for this approach. Then I will briefly comment on the standardization progress. Afterwards, I will put that into a broader context in terms of the overall network transformation. And then I will give you some brief insights what we are doing at Deutsche Telekom in terms of prototyping and trials in that space before I will conclude with some kind of success factors and challenges. Okay, I think so far everyone is familiar with the fact that operators are providing two basic connectivity propositions, fixed connectivity and mobile connectivity. And of course, you all know connectivity is the core business of the industry, mainly connectivity to the internet. And so far, still we have highly separated worlds, we have to say. We heard that already in the introduction. It's not only different fixed and mobile propositions in terms of technologies, it's also different in terms of standards, how far systems are really standardized. It's different in terms of ecosystems, in terms of life cycles, and so on and so forth. And therefore, we have a lot of work in front of us to converge the things more, but we are convinced at Deutsche Telekom, since we position ourselves as an integrated operator, you know that beyond fixed connectivity and mobile connectivity, a new kind of connectivity, which we name converged connectivity, will play a more important role in the future for two major reasons. On the one hand, it will provide benefit for the customers, and on the other hand, it will improve production efficiencies. So basically, the customer wants simple to be always best connected. He wants a kind of unified connectivity experience across different access networks, across cellular access, across Wi-Fi access, across mobile networks and fixed access networks. And today, we have still different experiences. On the other hand, from a production perspective, we are under cost pressure and we have to leverage all available fixed and mobile access assets. You know, access networks are by far the most expensive parts of the networks, and therefore we think these kind of convergence approaches in the mid to long term provide good opportunities for improved production efficiencies. That means overall converged connectivity propositions enabled by network-based FMC features is very important in the future. From that perspective, we sketched a kind of high-level, long-term target picture. Of course, it's very much top-down. It doesn't show any details. And this target picture is simply saying, okay, customers want to have an always best connected and seamless connectivity experience. That's quite obvious. And from an operator perspective, it's very much beneficial that the selection of networks and the steering of traffic shall be managed by the converged networks, shall be managed out of the network. From that perspective, two basic requirements come up. On the one hand, traffic steering and aggregation should be done by the appropriate network functions, and that would also include, if it makes sense, an aggregation, for example, of cellular access and Wi-Fi access to provide higher speeds, to provide better stability of connections. And second basic requirement is to use as much as possible converged network functions in a way that we consolidate network functions. Today, in many areas, we have quite similar functions in fixed networks, in mobile networks, and of course, there is a big efficiency potential to consolidate network functions. Of course, it must make sense from an economic perspective, otherwise it will not happen. Okay, and on the left-hand side, you simply see a high-level picture, what we think is converged connectivity all about. we think it's mainly relevant for portable and mobile devices because this device category customers use everywhere at home and on the move, and customers should have this kind of seamless connectivity experience across cellular and different kinds of Wi-Fi access. Of course, we have to state, this is not the first approach of bringing Wi-Fi access and cellular access closer together, you know that. And looking back, we had several kinds of standards, but unfortunately so far, for different reasons, they did not find their way to reality. Therefore, of course, and I agree with Robin at that perspective, maybe the 5G context, together with all the ongoing transformations, may provide a unique chance now to do it better, but of course, it is not for free. We have to put a lot of effort in it. And what this means, I will show you in a minute. But coming back briefly to the achievements in standardization, and that's also closely related to the opening speech, I think during the last 2 to 3 years, a lot of progress can be seen. And from that perspective, we can really state new kinds of standards provide a good foundation for 5G fixed mobile convergence. And of course, you all know from a 5G perspective, so far, mainly in focus is for the early deployments, enhanced mobile broadband. And you may know that famous triangular from ETSI, beyond enhanced mobile broadband, there is massive machine type communications, there is ultra low latency and reliable communication. But at least from my perspective, I think beyond these 3 dimensions in mid to long term, this kind of converged possibility supported by the related standards will also be very relevant. And you see here, as from 3GPP as well as from Broadband Forum, in first quarter next year, new kinds of standard will be available. On the one hand, access traffic steering, switching and splitting, which will enable this kind of network-based traffic management. Second important dimension from 3GPP perspective, 5G wireless and wireline convergence. And this is closely related to the BBWF activities in that space, wireless, wireline convergence. And the 2 organization bodies are working closely together here. And also briefly touched already, in addition, IETF will play an important role. Existing IETF standards will be selected or considered as protocols for release 16 5G core network standards. For example, multipass TCP has been selected for access traffic steering, switching and splitting for the third S, for the splitting part. And there are new initiatives at IETF in the area of multipass UDP, which may be a complement to multipass TCP. We are driving that from Deutsche Telekom, and I would like to invite you to join and to work also at IETF to make the required protocols available, for example, for a kind of enhanced ATSS in 3GPP release 17 timeframe. Okay, that is a brief overview in terms of standardization. When it comes to a high-level architecture picture, I think we have seen that already in one of the first slides. That is the top-down view from 3GPP and BBF, how a future converged architecture could look like. And in the core is the converged core network here, including a separation between control plane and user plane. We think that's very important because this allows much more flexibility in terms of implementation and deployment. And then you see different kinds of green bubbles. It's probably difficult to read here. These are new kind of gateway or interworking functionalities which are needed to link the fixed access network to the converged core. And in that area, of course, when starting to look deeper, of course, a lot of challenges are coming up because today, you know, all established operators have huge fixed access networks and mobile networks in place. and therefore we cannot change our infrastructure from one day to the other. And these kind of access gateway functions or fixed mobile interworking functions are new kind of functions which gradually may replace existing functions such as BNG. However, it's a migration issue, it will take time, and it's also a cost issue, of course, and therefore, yeah, there is, for the time being, I would say, a kind of gap between high-level target architectures, which are fine, which are necessary to have a clear view, where do we want to go. And on the other hand, of course, we have to state today we are not there, and we have to carefully design our migration steps to get there. Next picture, also coming from Broadband Forum, is illustrating this a bit more, how the different deployment scenarios for fixed mobile convergence may look like. But again, from that high-level picture to a real way forward, which is the most promising one for the time being, it's not 100% clear. Okay, the other thing which I briefly mentioned in the introduction is we have new standards, that's very good, but I think in our current industry situation, beyond 5G or next generation fiber technologies, we have overall some kind of huge transformations ongoing. And in that context, of course, we have a lot of new opportunities for more flexible implementations and deployments. But on the other hand, this big transformation towards new production models also needs a lot of changes, even in the companies, even in the provider side, to make it happen. This is a high-level slide where simply some dimensions of these network transformations, as we see it from Deutsche Telekom, are briefly addressed. On the one hand, disaggregation and softwarization will play an important role to drive flexibility and scalability. Second dimension, more in the space of management of all the functionalities. We think an overarching orchestration across different domains and life cycles is necessary, which we do not have available today. And third dimension, also nicely pointed out in the previous talk, around open APIs and open ecosystems. We think that's also very important to take into account the new opportunities which are coming from that direction. Okay, that means a lot of work ahead. And again, we have standards, we have, so to say, views and strategies how ongoing transformations may look like, but we still think that's also not enough. We also need to have early experiences, hands-on, to understand more potentials and limitations of new kind of technologies in the area of converged connectivity, and therefore I would like to briefly present you two types of prototyping and trial activities we have at Deutsche Telekom. On the one hand, we have conducted a trial in the area of converged connectivity for mobile devices. We have named this trial Zero Touch Connectivity Field Trial. You can see on that figure here how the trial looks like. It's a purely software-based solution for converged connectivity on mobile devices. And the software functions are running on the one hand in a so-called 5G FMC core in an infrastructure cloud, and you may consider these as early implementations of upcoming standardized functionalities. And for the device, we have implemented the functions in the device operating system, in the Linux kernel. We used the Google Pixel device for the field trials. We provided that device to about 35 customers in order to also learn more how is the customer experience when providing a new kind of connectivity where they do not distinguish between cellular and Wi-Fi, for example. And that means, for example, you can see it on the last bullet here, that we enabled a so-called auto-connect feature in the device. And that means that the customer was seeing a neutral connectivity symbol and no longer symbols for cellular, for LTE connection and Wi-Fi connection, for example. And I think the message behind is quite clear. The message to the customer is, dear customer, we are taking care for your connectivity. We provide you an always best connected experience, and no longer you have the hassle to think about is it better to switch on or off Wi-Fi? What do I need to do to have a good connectivity experience? And in terms of traffic aggregation, in our implementation, we used multipath TCP in the device and also the related functions in the network. And with that, for example, we were able to achieve in operational networks peak rates of more than 700 megabit per second on a standard device. Okay, second proof of concept we have implemented and already shown also, for example, at the Open Network Foundation, has been in the area of C-plane, U-plane split and in the area of embedded virtual network functions. What we did here is that we implemented on a switching hardware platform some user plane functions for packet pushing, and we learned from all that implementation work. For the time being, it's much more efficient to implement functionalities which have high performance requirements on dedicated hardware, and of course, in addition, we can implement and deploy control plane and other network functions on standard compute hardware. And we think this approach for the next, I would say, 5 to 10 years is probably highly relevant. Of course, it's virtualized. However, which kind of hardware architecture will be used depends very much on the functions you want to deploy and you want to run. Okay, with that, I would like to conclude. And my conclusion consists of a number of success factors we see to make converged connectivity happen, a number of challenges we need to address. First dimension is we need device support, in particular when it comes to converged connectivity for mobile devices. Of course, the device, and in particular the device operating systems, need to support this. And looking back to previous standards, for example, ANDSF or also LTE Wi-Fi aggregation, why did it fail? Because there was no device support. And therefore, that is, from our perspective, one of the most critical issues. But also for the home gateway space, as pointed out by the previous presentation, we need to follow new approaches. And for example, for that 5G residential gateway being defined at Broadband Forum, of course, we also need the appropriate implementations to make that happen. Second dimension, cost-efficient implementations, deployment, and operations. So far, there is not very much experience how that could look like for that converged functions in the networks. Of course, softwarization will be important. We need to figure out more what will be the role of open source. We need to understand better, which I already mentioned by the example, how universal or specialized compute hardware should be used and how these things can be combined. And also we need to understand in terms of deployment, what are the right topologies? Is it better to deploy in a very centralized fashion as we do, for example, today for mobile core functionalities? Or is it better to have a more decentralized deployment? Of course, edge computing is a quite famous topic. However, we need to figure out what does it really mean in terms of new functionalities, in terms of costs, in terms of maintenance, and so on. And last but not least, as mentioned several times, we need to develop the right migration strategies. Of course, we will have at the beginning, when deploying new functions, a coexistence with legacy infrastructure. when devices will come up with new functionalities, of course, at the beginning, penetration of these kind of devices in the market is low and will grow step by step. And also, we need to understand more, and sometimes I have the impression this is not all the time considered in the right way, that in particular in coming from a fixed access perspective, there are a lot of regulatory constraints and requirements which need to be taken into account to come up with the right architectures and the right strategies. So far, thank you very much.